Okay, well, for the last subject of this video series so far, at least, um, is going to be discussing the isotope and the ion. So, let me see if we can spell this out. Isotope and ion. So, in this case, an isotope, uh, I'd rather just use this example. So, an atom is basically essentially has this definition, I should say. It has protons equaling neutrons equaling electrons. So when you have what's called an isotope, and let me say ISO abbreviated, um, in an isotope configuration, you have protons equal to electrons, and I should be using a smaller case E for this and putting a little negative sign, but we all know what I'm talking about here. Protons are equal to electrons, but they're not equal to the neutrons. So the neutrons um, are variable depending on what you're working with. And then you have an ion, where again it's abnormal in the sense where you have protons that are equal to neutrons, but they're not equal to electrons, which we saw an ionic bond earlier, and you can see how that actually occurs. So, one particular thing that is to be noted about this is the activity of the isotope, because remember that a neutron is a neutron, and actually let me do this over on this side. Neutron is 1/2 of the um, atomic mass. Put that like that. So it's 1/2 of the atomic mass. So this is going to have a strange mass in a sense, or you kind of wouldn't be able to tell what the mass is, and you'll see what I'm talking about. The best way to look at this is with looking at examples. So let's go ahead and pull out a couple examples. So if I were to give you a test question of here's something very simple, an isotope with an atomic number of 16. So isotope, and it has an atomic number of 16. So what does atomic number mean again? Well, it's not atomic mass. Generally, this points to the amount of protons being 16. That's the first thing I think of anyway. So what we know about atoms is that normally the protons equal the neutrons equal the electrons. So with isotopes, we see that the protons are going to be equal to the electrons, but we're not so sure what the neutrons are going to be. So let's take a look at here. So we know that the protons are 16 definitely. The electrons are equal to the protons, so they're going to be 16 definitely. The neutrons we're not so sure about, but we can see from this formula that if this is 16 and that's 16, we know neutrons are definitely not equal to 16, so this is going to be equal to anything else than 16. So that's one way to determine, just get a perspective on how to answer a question if I asked you how many protons, neutrons, electrons were in an isotope with an atomic number of 16. Let's go ahead and continue. And let's see, let's work this time with an ion with an atomic mass of 8. So an atomic mass of 8. So what do we know about this? So we discussed in an earlier video that atomic mass, let me put this, atomic mass is equal to 1/2 times the atomic number. Alright, so basically this is an ion. So what do we know about ions? Alright, well, an ion, its basic definition, is consisting of protons that are definitely equal to neutrons, but electrons are not so sure about. But this is good in a sense, because what were the two most important factors when concerning mass? Exactly this, protons and neutrons. So here's a hint that there's not really going to be a conflict here. Maybe if this was an isotope, yes, but there's not really going to be a conflict, because we know exactly how many protons and neutrons we have, and it's only half of the atomic mass is half of what's there. So essentially, the simple way to figuring this math problem out is finding half of this atomic mass 8, because actually I should say a better way to calculate atomic mass. I think that formula is wrong, which is why I'm getting all stuttery. Is really the atomic mass is equal to protons plus neutrons, and they're equal to each other. So what plus what is the same number, that comes out to 8? Well, it's 4 plus 4. So we know protons are equal to 4, neutrons are going to be equal to 4, and again, we have this 4 over here, and we know it's not equal to E, so we know electrons are equal to anything else other than 4. Alright, so here's a trick question. Oops, I think I might have just made the screen blink a bit. Got I think another minute or two left. So, trick question, I guess. Atomic mass is equal to 8 of an atom. Okay, atomic mass of an atom is equal to 8. So, put on the Jeopardy song and tell me how many protons, neutrons, and electrons it has. Well, let's analyze this again. Atomic mass, which is 8, is equal to protons plus neutrons. And when we're dealing with an atom, we know protons are equal to neutrons are equal to electrons. I didn't say an isotope or an ion. This is normal. So essentially, this is a simple matter of everything being 4, 4, 4. So, alright, let's move on. Let's see, how much time do I have left here? Ooh, barely 1 minute. So, let's try this one more time. Oops. So if I give you an isotope, an iso abbreviated, with a mass of 8. Okay, well, the mass is going to be protons plus neutrons. Protons plus neutrons is going to become that 8. However, in an isotope, protons are not equal to neutrons. So this could be a 6 and this could be 2, but it's not going to be 4 and 4. So really, for everything, protons, neutrons, and electrons, we have a question mark. And why for electrons too? Because we don't know exactly how many protons we have here. This could be a 3, and this would be a 5 over here. So that's also a question mark. Okay, and I think I'm just about out of time. So imagine other scenarios and test yourself.